In this video, we are going to see how to solve a simultaneous equation by means of matrix. And later, let's see how to utilize this method for solving an electrical network using mesh analysis. Let's start the topic with simple examples. Here two examples are there. Here the question is represent the given equation in matrix form. Also show how to solve the variables associated with these simultaneous equations. Here first case is A. As seen here we can have two variables x and y. In second case, we can see there are three equations having variables 3, that is x, y, z are the three variables associated with second case. Here the first part of this problem is we need to represent these equation in matrix form. Before that, here A1, B1, A2, B2 are the constants. They are the coefficients of x and y, the variables. A1, B1 corresponding to coefficient of first equations. A2, B2 corresponding to coefficient of second equation. C1 and C2 are constants. Let's consider this first case. So how many variables are there? There are two variables. So we need the 2 by 1 matrix like this, x and y. How matrix multiplication is done? It is multiplied row entry with column entries of other matrix like this, a1x plus b1y like this. What is C2? C2 is equal to a2x plus b2y is equal to C2. A1, B1, A2, B2, this matrix is nothing but coefficient matrix of these equations. It represents the coefficients of the variables. That matrix is usually referred to as characteristics matrix. So this is the matrix representation of this equation. Here x is the first variables. So first column entries are corresponding to the coefficients of x in first and second equation. Similarly, second column entries are the coefficients of y, that is the second variable in first and second equation. These are the constant corresponding to first and second equation. What is the determinant of this characteristic matrix? We can represent determinant of this matrix by this notation. How to find out this determinant? It is nothing but a1 b2 minus a2 b1. In this way we can calculate the determinant of 2 by 2 matrix. Now let's see how to solve this equation using matrix form. That is how to find x and y from these equations. The solution method is simple. Here number of variable is 2. So we need to calculate only determinant of 3 matrices and some rule that is sufficient for finding out the value of x and y. So we know this is the constant coefficients corresponding to the variables or characteristic matrix. That determinant we can call it as delta. This is delta. Whenever we are seeing delta, it indicates that it is the determinant of this coefficient matrix. That is a1 b2 minus a2 b1 in this case. Now, in order to find the first variables, what we are going to do is, what is the first column entry over here in this constant coefficient matrix or characteristic matrix? A1, A2. What we are going to do is, that matrix first column entry is removed. We are retaining what? B1 and B2. I will repeat. In order to find out x, that is the first variables, what is the coefficient corresponding to x? It is the first column entry. So we are removing first column entry from this matrix and retaining all other column entries. In this case, only second column entry is available. And instead of this removed position, that is removed A1 and A2 position, this C1 and C2 is inserted. C1 and C2. So C1 and C2 is inserted in which column? First column. We can call it as A1 matrix. Okay. Determinant of this one, determinant of A1, we can call it as delta 1. So that is shown here. So x is nothing but, or x can be calculated in this manner. It is the ratio of delta 1 to delta. We know what is delta. Delta is determinant of this constant coefficient matrix. That is a1 b2 minus a2 b1. What is delta 1? In order to find out the first variables, we are firstly removed this first column entries. A1 and A2 is removed by retaining all other column entries. Into this removed column entries position, we are replacing what? C1 and C2. Then that we can call it as, that matrix we can call it as A1 for simplicity, just for notation. And determinant of that matrix, C1, C2, B1, B2, that determinant we can call it as delta 1. So x can be evaluated by means of this expression, delta 1 by delta. What is delta 1? It is the determinant of this matrix. It is C1, B2 minus C2, B1, all divided by this one delta, A1, B2 minus A2. Similarly, how to find out y? In order to find out y, what is the coefficient corresponding to y variables? It represents second column entries. A similar way, what we are going to do is, in order to find out, say A2 we can call. In order to find out A2, what we are going to do is, we are removing the second column entries, retaining all other column entries. Here, we can retain A1 and A2. Into this removed position, we can insert what? C1 and C2. Then determinant of this matrix, that is A2, that we can call it as delta 2. So x is delta 1 by delta and y is delta 2 divided by delta. So as I mentioned earlier, if we can have two variables simultaneous equation by means of determinant of three matrices, that is delta, delta 1 and delta 2, we can solve the variables. Y is equal to delta 2 by delta. What is delta 2? A1 C2 minus A2 C1 divided by A1 B2 minus A2 B1. So this is the method of solving a two variable simultaneous equation UT using matrix form. Now let's see this one. This is also very simple. So how to represent this in matrix form? So first column entry is corresponding to x, like this. A1, A2, A3 will come. Second column entry is this one, B1, B2, B3. Third column entry is C1, C2, C3. And how many variables are there? Three variables are there. The size of this matrix is 3 by 1. So size of this matrix is 3 by 3. And size of this matrix is 3 by 1. So when we are multiplying a 3 by 3 matrix with a 3 by 1 matrix, answer is 3 by 1. So the constant matrix size is 3 by 1. Okay. Similar way, how to solve this problem? How to solve these variables? Delta 1 by delta gives what? X. Delta 2 by delta gives y. Delta 3 divided by delta gives z. Clear? So how to find out delta 1? Delta, in order to see that one, let's see this matrix, determinant of this matrix. Delta only I am showing over here. So this is our matrix. What is the name of this matrix? Characteristics matrix. This is the characteristic matrix. Suppose we need to find out the determinant of this matrix, how to do that? So in general, I am showing that one. So A1 into, so when we are considering this A1, we need to remove this row and column. Remaining square matrix is this one. So A1 into B2, C2, B3, C3 will come. Then minus will come. How minus is coming? That is shown over here. Then minus B1 into, you need to remove this column and row. Remaining entries are A2, C2 and A3, C3. Then plus C1. Remove this column and this row. A2, B2 and A3, B3. So when we are finding out this determinant of this part, these parts, and substitute over here, you can obtain determinant of a 3 by 3 matrix. This is A1 into B2C3 minus B3C2. This is minus B1 into A2C3 minus A3C2. Then C1 into A2B3 minus A3B2. In this manner, you can calculate delta 1, delta 2 and delta 3. And one more point, how to obtain delta 1, delta 2 and delta 3. In order to find out x variables, you need to replace the first column entry and replace it with what? D1, D2, D3. Then that matrix is delta 1. If we are removing B1, B2, B3, that is second column entry, into that position you are inserting D1, D2, D3, that is delta 2. The determinant of that matrix is delta 2 and so on, delta 3 also. This is the way of solution of simultaneous equation using matrix method. Now let's see how to utilize this one for solving electrical network using mesh analysis. It is also used for nodal analysis that we will see in coming videos. So before entering into that, let's see the basic difference between mesh and loop. As we discussed in previous video, loop is nothing but it is a closed path of the network. It is the closed path of the network. We are starting from one point, reaching into the same point through journey after journey, then that is a closed path. So in this case, in this network, this path ABDA is one loop, BCDB is another loop, ABCDA is another loop. Now let's see what is mesh. Mesh is also one loop, but inside loop there is no further loop. That is the simple meaning of mesh. Mesh contains only single loop. It is a loop in which inside mesh there is no further loop. So a mesh is the most elementary form of a loop and cannot be further divided into other loops. So in this case, when we are considering these outer loop A, B, C, D, A, it contains two inner loop A, D, B, A and B, C, D, B. So a mesh, as per the definition of the mesh, a mesh doesn't contains other loop inside it. So this third loop is not a mesh. These two things are loops, that is ABDA and BCDB are meshes. Mesh analysis is a most easier and common method in order to solve an electrical network. The basic law utilized for solving an electrical network using mesh analysis is Kirchhoff voltage law. Algebraic sum of voltages in a closed loop is 0. So here we need to consider meshes only. That's why this analysis is termed as mesh analysis. How many meshes are there here? Here we can have two meshes. So how many loop equation, how many mesh equation will come? Two mesh equation will come. What do you mean by mesh equation? Mesh equation is nothing but KVL equation in respective meshes. Let's see all these things in detail. Now let's see how to solve an electrical network using mesh analysis. For that, let's consider a simple problem. Here the question is solve I1 and I2. Here two meshes are there. These are somewhat similar to this network. So two meshes are there. This is one mesh ABDA and second mesh is BCDB. Here we need to solve, we need to find out the value of I1 and I2 using mesh analysis. So in order to solve a network, electrical network using mesh analysis, you need to follow some steps. Here the steps are, so first of all you need to identify meshes, and into the identified mesh you need to assume the direction of current. If current direction is already given, that you can take it. Otherwise you need to assume. So here two meshes are there as I mentioned earlier. Current direction is already shown, so nothing to worry about that first point. Next thing is that in each meshes you need to write mesh equation. What is mesh equation? Mesh equation means you are applying Kirchhoff voltage law in that mesh and writing down that KVL equation. That equation is known as mesh equation. Okay, so in all loop or in all meshes, you need to find out KVL equation. Then you can obtain mesh 1, you can obtain one equation in terms of the variables I1 and I2. In loop 2, that is in mesh 2, you can obtain another equation in terms of the variables I1 and I2. These are simultaneous equations. You can solve the simultaneous equation by means of matrix method, as I mentioned earlier. Now we identified the meshes. How many meshes are there? Two meshes are there. So here we need to find out mesh current I1 and I2. I1 and I2 we need to calculate. So next step is we need to write mesh equation, that is KVL at each and every mesh. Let's take mesh 1. What is mesh 1? A, B, D, A. So it is to be noted that when we are taking any one mesh, here we taken which mesh? Mesh 1. So when we are in mesh 1, that mesh current is treated as positive. That direction is taken as positive. So here we can see that this 20 ohm is common to both mesh 1 and mesh 2. What is the direction of current I2? I2 is opposite to that of the mesh current I1. So the sign of I2 we need to take when we are considering mesh 1 as minus I2. So what is the current flowing through 20 ohm resistor when we are considering mesh 1? It is I1 minus I2. Now we chosen the first mesh. First mesh current is assumed to be positive. So what is the next step? Based on this current direction, we need to mark the polarity, that is higher potential, lower potential point we need to mark. Here also plus 1 and minus 1 based on this direction of current. Now we know what is the current flowing through 40 ohm resistor. It is I1. What is the current flowing through 20 ohm resistor? As I explained earlier, it is I1 minus I2. Now we can take the sign. How to fix the sign? We can take the second point, clear, for all passive and active elements. If we are taking in that manner, KVL equation can be written as 120 minus 40 into current. What is the current? I1 minus 40 into I1. Then the second point polarity is minus 20 into what is the current? I1 minus I2, which is equal to 0. That is the KVL equation in mesh 1. So when we are separating these coefficients of I1 and I2, here minus 40 is there, here minus 20 is there. So total coefficient of I1 is minus 60 and corresponding to I2 the coefficient is 20 and this is 120. When we are rearranging this equation, we can write down this equation as 60 I1 minus 20 I2 is equal to 120. Say this is your equation number 1. So now mesh 1 equation is over. Next let's take mesh 2, this part alone, that is B, C, D, B. When we are in mesh 2, what is our positive current? Positive current is I2. Since I2 and I1 are opposite, under this condition, current flowing through 20 ohm resistor is to be taken as I2 minus I1. Let's see that one. So this is the mesh 2 condition. This is your mesh 2. So first of all, we are assuming this current direction. This is already given. So this current direction is already given. Mark the polarity like this based on the current direction. This is higher potential. This is lower potential. This is higher potential, lower potential. This I1 is flowing in this downward direction. So that is marked over here. But this I2 is moving upward. So they are opposite. Now let's write KVL equation in mesh 2. So what is the current flowing through this 20 ohm resistor? As I mentioned earlier, when we are considering mesh 2, this current is taken as positive. So minus 20 when we are considering the second point entry or second point for fixing the polarity of voltage drops or voltages. So this is minus when we are moving from when we are moving in this direction, the polarity is minus. So that is written over here. Then minus 20 into what is the current? It is I2 minus I1. Then what is the current flowing through the 6 ohm resistor, 60 ohm resistor? That is minus 60 into I2 then second point corresponding to 65 volt is the polarity is minus, so minus 65 will come. So rearranging this one, we can write down this equation: 20 I1 minus 80 I2 is equal to 65. Let's write this equation over here. Now we can represent these first and second equation in matrix form like this. So the coefficient of I1 is 60, and for second equation it is 20. Coefficient of I2 corresponding to first equation is minus 20, corresponding to second equation is minus 80. Then two variables are there, so it is a 2 by 1 matrix, I1, I2. C1, C2, that is constants, are 120 and 65. As I explained earlier, how to find out I1? It is delta 1 by delta. What is delta? Determinant of this matrix, constant coefficient matrix. What is delta 1? We are removing the first variable coefficient, that is first column entry, fully into that position. We are replacing, or we are placing this constant matrix element, that is 120. Instead of 60 we are placing 120, instead of 20 we are placing 65. Determinant of that matrix gives delta 1. Similarly, when we are replacing the second column entries with this and finding the determinant of that matrix, that gives delta 2. So this is delta. Delta is obtained as minus 4400. Delta 1 is obtained as 8300, and delta 2 is obtained as 1500. So when we are using this equation for finding out I1, I1 is obtained as 1.886, and I2 is obtained as minus 0.341 ampere. So what is the meaning of minus 341 ampere? Our assumed direction is opposite to the actual direction. So the actual direction of current is not like this. Actual current direction through this branch is in this way. So that is the indication of this minus 0.341 ampere. Now I am giving another work to you. Here the question is with three variables. This is the electrical network. As I mentioned, you need to identify meshes and assume the current direction. Since meshes and current direction is already well known when we are looking this figure, so nothing to worry about that one. So now what you need to do is you need to write the mesh equation in all meshes. Mesh 1, let us consider this one. Mesh 2 is this one. Mesh 3 is this one. Then as we solved here, you need to write down the KVL equation and solve that KVL equation using matrix form. I will explain the first loop. Remaining things you need to do. So when we are considering this one, identify meshes. How many meshes are there? There are 3 meshes. And what are the loop current you need to find out? I1, I2 and I3 are the 3 loop current you need to calculate. Okay. Then let's take mesh 1 for writing KVL equation. So this is your mesh 1, separately I took. And through this 30 ohm resistor, I3 is flowing in this direction. Through these 50 ohm, I2 is going upward, but I1 is flowing downwards. So when we are considering mesh 1, our assumed positive direction is current direction corresponding to I1 alone. When we are considering mesh 2, this current direction is taken as positive direction. When we are taking mesh 3 KVL equation, this I3 current direction is taken as positive for analysis. Let's see the first case, mesh 1. So I3 is opposite to I1. Current flowing through 30 ohm resistor is I1 minus I3. Similarly, I2 and I1 are opposite direction. So current flowing through 50 ohm resistor is I1 minus I2. Now let's see mesh equation. Similar way, let's take the second entry terminals. Polarity for fixing the polarity of voltages in closed path. Say we are starting from this potential, that is 100 volt. The second point polarity is plus, so it is 100. Then 60, its sign is minus. What is the current? I1 minus 60 into I1. Here minus, this minus is coming. 30 into what is the current? I1 minus I3. Here this minus will come. this is coming over here. 50 into what is the current? It is I1 minus I2. Then one more voltage is the second terminal polarity is negative. So minus 20 is coming. That is 0. Algebraic sum of voltages, that is EMF and voltage drops in a closed path, is 0. That is written over here. Now simplifying, we can obtain this equation 14I1, or you can solve from this equation. Here what I done is I divided the equation with 10. No need of that simplification also. You can solve with the big figure also, no problem. So finally, mesh 1 equation we can write it as 14I1 minus 5I2 minus 3I3 is equal to 8, or 140I1 minus 50I2 minus 30I3 is equal to 8. Similar way, when we are considering mesh 2, this is for mesh 2. Now I am giving some hints when we are considering mesh 2 and mesh 3. When we are considering mesh 2, I2 is taken as positive. So current through 50 ohm is I2 minus I1. Current through 40 ohm is, their polarities, their directions are opposite. So one is I2 is going in this direction. This is I2. I3 is going in this direction. So current flowing through 40 ohm when we are considering mesh 2 is I2 minus I3. That you need to consider for writing mesh equation or KVL equation in mesh 2. When we are considering mesh 3, I3 is taken as positive direction. So 40 ohm and 30 ohm are common impedances or resistances. So current through 40 ohm is I3 minus I2. Current through 30 ohm resistor is I3 minus I1. Write down these three equations. So these three equations are three equations in terms of these variables I1, I2 and I3. Represent that simultaneous equation in matrix form. Find delta 1, delta 2, delta 3 and delta. And finally solve I1, I2 and I3.
That work is left to you.